Alright, this is June 2017, and we're looking at questions 11A and B. The question says, A is the matrix 3, 5, 2, 4. B is the matrix 4, 3, 0, minus 1. We're asked to what? Show by multiplying A and B that the vector product AB is not equal to the vector product BA. Well, it's simple. To show that they are not equal, you have to first find what? AB and find what? BA. And once you do that, you'll be able to see if they are equal or if they are what? Not equal. Alright, so let's first find AB. 3, 5, 2, 4, that is A, multiplied by B, this is what? 4, 3, 0, minus 1. When we multiply two matrices, we multiply what? The row of the what? First matrix by the columns in the second matrix. How do we multiply? How do we multiply a row by a column? The first element in the row by the first element in the column, and the second element in the row by the second element in the column. So 1, 2, 1, 2. Three fours. 2 times 3. This is 12 plus 6. Moving over to the right column. 3 times 0. 2 times minus 1. Bottom row, left column. 5 fours. 3 times 4. 5 times 0. 4 times minus 1. This is 18, 32, minus 2, minus 4. Did you get this? Let's find BA now. Let's find BA. Alright, so BA means I must put B first. 4, 3, 0, minus 1. Multiply by 3, 5, 2, 4. 1, 2, 1, 2. 4 3s, 12. 0 times 5 is 0. Right column. 4 2s is 8. 0 times 4 is what? 0. Bottom row. Left column. 3 3s. Minus 1 times 5. Move over now to the right column. 3 2s. Minus 1 times 4. So this turns out to be 12, 4, 8, 2. Did you get that? So there it should be abundantly clear that what? This is AB and this is what? BA. So it is very clear. Do they look anything like they're the same thing?
No, sir.
Therefore, AB is not equal to BA. Did you do that?
Yes, sir.
B, the B part of the question. Sorry, before B. Then it says what? Find what? A inverse. So this is I. Now we're at I. A inverse 1 over the determinant of A times adjoint A. The determinant of A. The determinant of A is this times this. So it's what? 3 times 4 minus 2 times 5. 12 minus 10. This is what? 2. So A inverse is what? 1 over what? 2 times what? Adjoint A. You're going to what? These two we're going to switch around. So this is what? 4 and 3. These two stay where they are, but their signs change. So minus 2, minus 5. This is 4 over 2, minus 2 over 2, minus 5 over 2, and 3 over 2. Please note, multiplying by a half is the same as saying divide by 2. This is what? 2 minus 1 minus 5 over 2, 3 over 2. Did you get this?
Yes, sir.
That's A inverse. What else did they say? We're at what? Right? This says what? Write the 2 by 2 matrix representing the matrix product A inverse. Well, everybody should know that. When you multiply A by A inverse, what are you supposed to get?
Identity.
When you multiply a matrix by its inverse, you're supposed to get the I matrix. So you're supposed to get I. And this is I is 1, 0, 0, 1. Did they say you should show it? Did they say show that that is equal to that?
No,
All they said you should do is what? Write it down. So everybody saw that, right?
yes, sir.
Write the 2 by 2 matrix representing the matrix product A inverse. All they asked you to do is to write it. Did anybody calculate it? They didn't ask you to do that. They say you should what? Write it. Just write it. You're overdoing the question. Let's go. B part of the question.
Right, the correct pair of simultaneous
We have 3x
plus 2y
plus 2y is equal to 1. And what?
5x plus 4y
5x plus 4y is equal to what? 5. They said that we should what? Write this as a what? Matrix equation. Are you ready?
yes, sir. 3, 5.
It says, write the following as a matrix equation. I.
5.
Alright, the coefficient matrix 3, 5, 2, 4, multiplied by what?
Y
X, Y is equal to
1, 5.
1, 5. Did you do that?
Yes, sir.
Next. I.
Right.
Write the solution of your matrix equation in BI as a product of what? 2 matrices. Now, this is in the form AX is equal to B. Now, how do we solve a matrix equation in that format? To solve a matrix equation of this form, I must write back the x on the left hand side and then multiply b on the right hand side by what? A inverse. So this is A inverse B. So therefore, in order for me to solve it, I have to first find what? A inverse. Ladies and gentlemen, A inverse is 1 over the determinant of A times adjoint A. Alright, I think that's what I was looking for. Isn't this A? Let me know somebody. Smart A. Isn't this A?
Yes, sir.
So this is what?
Inverse.
So we did that already. It means that X. What is X? X is what?
XY.
XY is equal to what? A inverse, which is what? A inverse is what? 1 over what? 2 multiplied by what? 4 minus 5 minus 2, 3. Multiplied by B, which is what? 1, 5. You know, I wouldn't stop there. Did he ask you to find out what is X and Y? Look carefully. Did he ask you to find out what is X and Y?
No, sir.
No. He said you must write it as the product of two what? I would not stop there. I would use this, but I would use this. This is 2 minus 5 over 2 minus 1, 3 over 2 multiplied by what? 1, 5. Then I would stop. Then I would stop. Did he ask you to solve it? Did he say solve? No. He simply said what? Write it as the what? Product of what? Two matrices. Isn't this the product of two matrices?
Yes, sir.
I would stop exactly there. Doing more is overdoing the question. He said write the solution. Write your solution, which is what? X, Y, as the product of what? Two matrices. Why I wouldn't stop it here? Can I tell you why I wouldn't stop it here? Because it is two matrices and a what? Number. He said I should write it as the what? Product of what? Two matrices. I wouldn't stop until I just have what? Two matrices. Then I would stop. It did not say to me find the value of X or Y.